story so far. Mass refers to how much stuff a thing contains. Weight refers to the rate at which that amount of stuff is being accelerated towards the Earth. In other words, weight is just another way of saying force of gravity. An object's mass never varies, but its weight can go up or down depending on the force of gravity acting on it in various parts of the universe. And now, work. These barbells have a mass of 120 kilograms. Since they are resting on the surface of the planet Earth, we know that the force of gravity acting on them is about 10 times that number of newtons. It takes a very strong man to lift something that weighs so much. Because if the barbell is being pulled down by a force of 1,200 newtons, it must take 1,200 newtons of force to hold it up. Of course, if we were on the moon, where the force of gravity is only 1/6 that of the Earth, anybody can do it. But we're not on the moon. That looks like hard work. But how much work? 1,200 newtons worth? To lift the barbell? How far? Exactly 2 meters. But what if you only lifted the barbell half that distance, say 1 meter? Surely that doesn't take as much work as lifting the barbell 2 meters. When you lift the barbell all the way up, you're doing 1,200 newtons times 2 meters worth of work. When you lift it only halfway up, you're doing half that amount of work. 1,200 newtons times 1 meter. In fact, this is how you measure work in physics. Work equals force times distance. Here you're doing 1,200 newton meters of work. And here you're doing 2,400 newton meters of work. That's simple enough. But suppose that after the show, the strong man discovers that his car is stuck in the mud. He pushes it and pushes it, but it won't budge a millimeter. And suppose that at the very same time, the clown, who hasn't got a car, is in the act of picking up the telephone to call a cab. Which of them would you say is doing work at this particular moment? The strong man or the clown? The clown. Because work equals force times distance. And although the telephone receiver only weighs about 2 newtons, while the strong man's car weighs perhaps 15,000 newtons, when he lifts the telephone receiver, the clown is applying a force of 2 newtons through a distance of 50 centimeters, let's say, or half a meter. And therefore, he's doing 2 newtons times half a meter of work, which is 1 newton meter of work. The strong man, on the other hand, may be exerting thousands of newtons of force. But since the car's not moving, there's no distance involved, and the poor man isn't doing any work at all. A force of even thousands of newtons times 0 distance equals 0 work, whereas a force of only 2 newtons through a distance of only half a meter does equal some work, even if it's only 1 newton meter worth. But it's a bit awkward to keep on talking about newton meters of work. So physicists have borrowed the name of a famous British scientist, James Prescott Joule, as the measure of work. 1 joule is the amount of work done when 1 newton of force is applied through a distance of 1 meter. That's to say that 1 newton meter equals 1 joule, which can also be written like this. So the clown did 1 joule of work when he lifted the telephone receiver. And the strong man did 2,400 joules of work when he lifted the barbell. But of course, when he tries to move his car, it's a different story. He does 0 joules of work.
That's